Hello everybody, how's everybody doing? Hope you're doing fine. And today we have another exciting day. I'm going to start with just a review of the extinction issue, okay? And just wanted to mention that there were a couple issues there, one was the homework. Nobody did it, which may mean many things. Could be not interested, or you don't have a proposal, or you're still thinking, you're still coming up with stuff. And the homework consisted essentially in coming up with an alternative mechanism for killing man, killing our species, making it go extinct by way of starvation through the food chain. Okay. So far as I know, there are two proposals on the table. One is from this fellow Guy McPherson. He says it's going to be the climate. The other one's the one I'm proposing, and that's that the economy is going to fall apart. Where do I get this? Well, when you do Extinction 101, you go back in time, you find out that the past species, those that disappeared in mass extinctions, did so through the food chain. And so I think food is the issue. I think that's economics for the animals. That's the resource that a wild animal manages. And so there's no reason to think that if all animals in the Permian, in the Triassic, in the Jurassic, in the Cretaceous, all of them disappeared. When they disappeared in a mass extinction, they disappeared because of food. There's no reason to think that man is going to disappear in any other way. Therefore, we don't have to worry about looking through the telescope to see if a comet comes down or an asteroid. We don't have to look through the microscope to see if a bug is going to kill us. We don't have to worry about, as far as I'm concerned, climate change. The only thing we have to worry about is food. And yeah, when you look at that, if you take away food from man, I think he's going to die, right? How long can you last without food? Maybe a month, 2 months? And yeah, if our global economy falls apart, then we lose food. So I do have a reason, I do have a mechanism, okay? And that's the reason I'm putting this challenge, this homework for whoever wants to pick it up. The glove is in your face. And you got to do Extinction 101 before you do Extinction 102. 102 is man, 101 is extinction. First, you need to explain extinction, okay? What the mechanism of extinction for a past species was. And hopefully you don't come up with what the establishment has come up with, asteroids and volcanoes and supernovas and all this other nonsense. The other thing is, you may have a different theory for the extinction of man. Hey, I'd love to hear it. So, don't tell me how man is not going to die. Tell me how he is going to die. Give me a mechanism, okay? Okay, anyways, talking about the end of time, at least for man. Today's a time day. We're going to talk about time. And a good place to start is in the history of time. I'm just going to give a very brief history, okay? Just a big, whoa, I went out of focus there. Hello, I'm back. Hi, Tesla. So what's the deal with the history of time? Well, just in general terms, right? Keep going out of focus. I don't know why. Camera doesn't like me, I guess, today. Well, if I go out of focus, I'll keep talking. We have an issue with time in that we started a long time ago doing calendars. And these calendars, essentially, there were all kinds of calendars out there. They reflected essentially the farming world, the sowing season, harvesting, the seasons. They realized something changed throughout the year. And eventually they figured out, that either the sun was going around us or we were going around the sun. Something was moving out there. There was nothing standing still. We did have moon calendars. A lot of cultures use moon calendars. The Greeks had 8 and 9 day weeks, so we don't we didn't always have 7-day weeks. And the other thing with the Greeks is they set the calendars also, like every 4 years they had the Olympics, and they set the calendars to the Olympics also. Well, Julius Caesar finally put a calendar that replaced the earlier Roman calendar, and he put 365 days in the calendar. I think that was already there, but he changed the starting point of the calendar essentially, and it was his son, his adopted son, which was his nephew Augustus, Octavius, and Augustus later changed the calendar to reflect Jules for July and August for August. See, you wonder why September is the 9th month when Sept is a 7. Why October is the 8th month when it means 8, right? And why it's the 10th month and so on. Well, they moved all September, October, November, and December, which were 7, 8, 9, and 10. They moved them to 9, 10, 11, 12. And in between they put 7 and 8, which were July for Julius Caesar and August for Augustus Caesar. Pope Gregory would change it many years later. There were some little issues there, and so they amended that. And what's interesting is that the minutes and seconds, they really didn't become important until the end of the 17th century, because until that time they had no way of measuring such fine points, at least as seconds. And so these came into being at the end of the 17th century. And so for this, you got to kind of look at a parallel between time and also the evolution of clocks. And so here's a little history of clocks, okay? Just a quick rundown. We started with sundials and water clocks, and they look something like this. You can see by looking at the type of clocks that we had in antiquity, you can see how we measured time in the old days. The first one down there is in Nabta Playa, Nubia in Egypt. They say it's anywhere from 6,000 to maybe 7,500 years ago, before Christ. And these were stones, and essentially it's a sundial, but it's for the seasons. And then you have the typical sundial that was used quite a bit in the old days. And that one's in Tarragona in Spain, the one that's in the center. Then you had the Egyptian water clock, the clepsydra as the Greeks called it, and they would measure how many, essentially when the bucket was empty, the funnel there was empty, then you had maybe 15 minutes were up because they would drip at a certain pace. And they also had different types of, here's another type of clock, actually not a clock, but it's a seasonal type of clock, okay, so keep that in mind, which is the Kukulkan serpent in Chichen Itza. And when the sun you can see the sun just making a shadow there or thinning it, and that was a serpent there. At the bottom you can see the head of the serpent, and so that would tell them when the equinox was around. You also had candle clocks, and this was used quite a bit in the old days. After, you're talking about in the AD area, right? Not in the BC. The Arabs used that quite a bit, and it looks something like what you see on the right. They had different markings, sometimes on the wall or behind it or whatever. And as the candle burned well, you knew that 1 hour went by, 2 hours went by, and so on. So these were our first attempts at creating clocks. And obviously, with those, you cannot measure seconds and minutes that accurately. So it was usually, some of these were used like the sundials. They were used to check how many hours of labor a slave worked or whatever, and so they would mark it, and then they would know more or less how many hours went by or whatever measure they had at the time with a sundial. So it was a very crude system, but it worked for many centuries. And we forget that, people in the old days, they did not have wristwatches, and they didn't keep track of time as carefully as we do today. Time has become more and more important over time, okay? Then we started with mechanical clocks in the 14th century. And here you get a couple ideas of what a mechanical clock looked like. They were a little bit cumbersome. They had these weights and gears. They moved around. They worked, but they were usually put in churches and so on, so that people could get an idea what time it was in the day. But it's not like you carried one of these on your wrist around, a wristwatch with all those gears. Yeah, so we had to improve the clocks before we could start timing things more accurately. And one of the first guys to come up with stuff was Galileo. And he came up with a pendulum clock. Okay, he designed it. And that's his design in the center, and a modern version of it on the right. And what it was is, again, gears and all, but this time it was run by a pendulum. Okay. And he designed it. He didn't ever build it. I guess his son tried to build it but never finished it. The guy who's going to finish one of these pendulum clocks is Christian Huygens. He's going to build his first one in 1656. And then he built more sophisticated ones. That one on the lower right is from 1673. Okay. So he started working on that. He also he also was good at trying to figure out, how to be able to carry a clock on a ship, because one of the big problems they had throughout the 16th, 17th century up to the 18th century was longitude. They couldn't figure out the longitude. They could figure out the latitude with the sun. If the sun was straight overhead, it was 12 noon. But you didn't know how far, you were along the longitudinal lines, And so one of the fellows who tried to fix that problem was Christian Huygens. He had his chronometer, little device that he made, but it was not very accurate, and so it was never accepted by the British. But the British, I remember Huygens was from Netherlands, and he was sponsored by the King of France, Louis XIV. But the British picked up on that and said, hey, maybe we can figure out a way to calculate longitude. And they put out a little reward there for anyone who could come up with something, and one guy did, and that was this fellow Harrison, John Harrison. He comes up with a marine chronometer. Okay, and again, this was the problem. The problem is a ship sailed, say, west. They could tell, where the sun was at that point if it was right overhead, but they could not tell you the longitude. And for that, they had to have accurate clocks that would tell you how far you ventured from England, right? And so clocks became more and more sophisticated over time. Well, again, time followed clocks more or less. They were in parallel. The problem comes really in the 19th century when we started doing some weird things with time. And forget about clocks now. Now we get into time, and some of the fellows involved with this revolution, because you could call it the time revolution, comes at the end of the 19th century, and it's a result of this ether. Okay, they were trying to figure out how light goes through the ether, time it, and figure out what it really was. Was it the waving of the ether and so on? Well, in 1887, Michelson and Morley run their interferometer test, and they show that there is no ether. At least to the majority of people in those days, that's what they concluded from their experiments. And this shocked a lot of people, and because they said, no, how can it be? If there's no ether, what is it that's waving? And to this day, we haven't answered that question, right? They don't know. The mathematicians don't know because they never figured out, they're only doing calculations. They never deal with objects. And that's the main problem there. But so what happened? Well, what happened was you had this group of people, these celebrities, okay? And these are the people who were going to start the revolution. I'm just naming a few of them here. There were others, okay? One is George Fitzgerald, who's the first one who picks up on the Michelson-Morley experiment. He doesn't like the results. And he says, and he starts proposing that maybe length contracted. That maybe the interferometers were squashed in the direction of travel. And, well, I don't know, a lot of people laughed at him, but then Hendrik Lorentz, who was also quite popular in those days, he picked up on that idea, developed his equation, in which he shows that it all has to do with the velocity of the object in relation to the velocity of light. And from there we get into the notion, this principle of relativity, that Albert Einstein is going to pick up later on. And he's going to talk about time dilation and all sorts of nonsense that came with special and general relativity. He develops his field equation, 1916. And it's going to be this fellow, Hermann Minkowski, and he's going to come up with a notion of space-time. He said that from now on, you can't separate time from space and space from time. We need 3 dimensions of space, and we need 1 dimension of time. And so he created this notion of space-time, this concept which later on is slowly going to turn into a physical object. And again, this is a major revolution, at least in mathematical physics, okay? Why is it? Well, here you have the notion of time dilation, the twin paradox. One of the twin girls goes out, comes back 30 years later, but one is 4 years older than the other one. And you wonder how this could be, how they can justify this. I mean, they justify it with equations, but the question is, how do you justify this physically? Does this really happen? And this is where the problem is. The problem is whether mathematics is the language of physics. You can do your calculation. You can, run your equations, figure them out. Is this going to really be the case in the physical world? And this is what you got to think about. I don't know. And then the question was, if Minkowski came up with space-time, what is this thing called space-time? I mean, what is it good for? What do we use it for? And here are some notions. This is one notion of what a field might look like, the 4-dimensional space-time field. This is the way they picture it, okay? Maybe this, it kind of looks like the ether, except that instead of particles, you have all this web of sorts, 3-dimensional web. So that's one notion. Here's the other notion, the more popular one today, and that's the fishnet. Mass weighing down the fishnet. You wonder what the white stuff is that serves as a background to the fishnet. And so they tell you, well, you're not supposed to take the analogy literally. Okay, that's the argument, that space-time is, what is it? Is it a mathematical concept or is it a physical concept? What are we supposed to do with it? A physical object, sorry. What are we supposed to do with this space-time? Are we supposed to take it literally? Are we supposed to laugh at it? Or what is this space-time for? I mean, here's what you got to explain. And here's the explanation they use. You can see that this analogy, so-called analogy, is used for something physical. And here it is. You see that the moon is rolling around the Earth, around this space-time like a roulette, like the little ball in a roulette. And so it's this space-time depression, or the depression in the fishnet, which is a physical interpretation. Okay, they say this is a physical interpretation. And what is it? A physical interpretation for why the moon doesn't fly out of the solar system. Okay, So is this, I'm not supposed to take this literally? Then what is the point of this analogy if I'm not supposed to take it literally? And so, yeah, we get to this point where we're doing double talk here. On the one hand, they say, look, you're supposed to take space-time because we proved it. We've done all kinds of experiments. Here are the equations. All that is settled, right? No argument. You can't even argue. Okay, I don't want to hear about any equation. I want to know why the moon doesn't run out of the solar system. That's all I want to know. Here they're showing you, and they say, well, it's a depression in space-time, and the moon rolls around space-time. Okay, so space-time, that means you're saying that time is warped in this circular depression, right? The edge of this depression, it's circular all around, anywhere you look at it, or you want elliptical, fine, no problem. The question is, here you have this depression, and you're saying that's what's preventing the moon from flying away. I mean, it's straightforward. And then the guy tells you, well, you're not supposed to take it literally. What have we learned? I mean, is it literal or not? We have to take it literal. I'm sorry, because that's your physical interpretation. And if it's not literal, if you cannot take it seriously, then we should laugh at it and discard it. We have no purpose for space-time. Anyway, space-time has grown over time to the point where it's just become a monster, especially that the time portion of space-time, right? It's that time portion that's driven people nuts, especially in mathematics, because, you know, since they do calculations and they do equations, they have to put that little time in there for just about everything. And so time has become a variable that a very important variable. You can't live without time in mathematical physics. Okay, that's the issue. And so I'm going to show you a few celebrities right here, okay, that what they have done with time, what notions they have developed with time, and you tell me if these people are rational. And these are all PhDs that I'm going to show you. Some of them are celebrities, TV celebrities. You've probably seen some of them around, or all of them. And you tell me if these guys are rational. I mean, keep in mind, these guys have a PhD. That means they went 10 years at least to university. They wrote their thesis for whatever. And this is what they learned. This is what they're telling you about time. Physicists, so-called physicists, mathematical physicists, you can call them physicists. But these people are going to tell you what they think about time. And I just want you to think about, you know, what they're saying. Okay, here's the first one. And this is going to be Roger Penrose. And he says that time is out there like, you know, like an individual, an independent type of entity, okay? Let me get it set up here. Here it goes. It says relativity is extremely well tested, something like 14 decimals, okay, places in decimal. So we know that this theory does describe the universe to an extraordinarily precise degree, so we have to take it seriously, okay? That theory tells us that we have to regard space and time as one thing. It's all out there as one thing. In the same sense as space is out there, time is out there. So now he's saying that, now Roger Penrose is saying that this thing is out there. Okay, you're supposed to take it seriously because first they proved it. Okay, proved it what? With equations. Then it says you got to treat time as something that's out there independently, like space supposedly is out there. Okay. So what do you think? Here's this guy saying that time is out there. What is out there? I mean, you can say that a cow is out there. Okay. You can say that something that is physical is out there. How can you say that a concept is out there? What sense does that make? And this is the problem that we're going to see. They're going to treat time as a physical object like saying, oh yeah, there's this thing, this ocean, this medium called time. We're going through time. We're going to travel in time. We live in time. So they're talking about they're talking about some kind of medium in which we inhabit called time. Okay, and this is going to be the fourth leg of space-time, keep in mind. Okay, so and here you're talking about a guy, you know, PhD, not only a PhD, he's a famous PhD, Roger Penrose, And this guy believes in this. He believes that there's a physical or some entity or some medium out there called time. And these are the guys that are influencing the majority of people out there on the streets. Okay, keep that in mind. Here's another one. And this is Stephen Hawking. Let me get him set up. And he's going to talk about negative time. You wonder about these people sometimes. Here goes. It says, if there's one thing that, he's questioned by this fellow, what would he like to be remembered for? And he says, imaginary time. People think it's something you have in dreams or when you're up against a deadline, but it's a well-defined concept. But it's imaginary time is like another direction in space. It's the one bit of work science fiction writers have used because they don't understand it. No kidding. I mean, I don't blame them for not understanding. I mean, do you understand this imaginary time? I thought all time was imaginary. You know, we've got negative time, imaginary time. What is all this nonsense? What do we need all this for? Is this to explain how the universe works? Imaginary time? And you might say, well, you know, it's a mathematical concept. Yeah, he puts it in his book, in his A Brief History of Time. He talks about imaginary time in there. Worthless garbage. Nonsense. Absolute nonsense. Really for people who lightly deal with physics, very, very tangentially, very superficially, and they say, oh, okay, imaginary time, what a great concept. We don't need this nonsense. This has nothing to do with physics or science, okay? So, yeah, and this guy invented imaginary time, so that was one of his pet peeves, okay? Here's another fella. This one just blew my mind. He's a professor at Berkeley, and this is what he says. Let me put it in there. It says, space and time are lightly linked in general relativity, but if you create more space, you're creating more time. If the expansion of the universe, starting with a Big Bang, is constantly creating more space, it must also be creating new time. And the newly created space is the space between the galaxies, and the newly created time is what we call now. If this theory is right, then we need a possible real test where we are creating new space. In other words, this guy, this is Richard Muller. He's a professor at Berkeley again, and this guy says that as you create space, you create more time. So, okay, so there's more distance between the galaxies, and that's the so-called space expansion. Fine, okay, well, let's concede that. What does that have to do with time? And he says, well, if space-time is expanding, it's not only space, but time is also expanding. You're creating more time. That's his so-called theory. Okay? It's gotten, you know, it's just unbelievable. And neither are we creating more space, neither time, but this is what these people believe. And these are professional PhDs, you know, they're teachers, they're professors, they're teaching the new generation of people, and they're the ones who get access to the microphones to talk to the average person out there. And what are they saying? They're saying that, you know, you're creating more space, you create more time. What is that? What can that possibly mean? And then when you say, well, what do you mean you're creating time? Yeah, it's the now. The now is expanding. See, they keep treating time as a physical object. All these folks, they treat it as some kind of medium out there. They don't know what it is. They can't define it. They never have. They say nobody knows what time is, but they're all experts at it. And they say, oh yeah, we're creating more space, therefore we create more time. Then we have imaginary time. And time is something that's out there, you know, running around by itself, like independent of us, or maybe dependent on us, right? Because you know, they're saying that, you know, every observer has his own notion of time, his own reference frame. So it's like your time is not my time. So we don't know what time is, right? But well, boy, do we talk about time. It's almost like extinction. We don't know what extinction's like or how to explain it, but everybody's got theory about extinction, no doubt there. Okay, here's another fellow. See if I can get, this is Jim Khalili, and he's a British guy who does quite a few documentaries. You can find him on YouTube just about everywhere. And this guy's going to say something that will blow the minds of a lot of people out there. He says, you don't have any free will. You don't have any free will because we have a blocked universe, okay? The future has already happened. And it's one of my arguments in my book where I say that, if that's the case, if the future is already there and God already knows what's going to happen, he knows it all, then what does that mean? It means that you're just a cartoon character. It's like, Bugs Bunny. Does Bugs Bunny have free will? No, Bugs Bunny typically has the will that the cartoonist put into the little picture, okay? So Bugs Bunny doesn't have any free will. In the same way, you don't have any free will if there is a blocked universe. And here you see what he says. Let me put it up there. Give me a second here. There we go. It says, if you take this block of four-dimensional space-time literally, it means you have to abandon free will. This is a PhD talking, okay? It means not only is the future preordained, but it's already there. It's already happened. So we're talking about the past, not the future. Okay? So what do you think? You have any free will? Do you think you have any free will, or do you think it's already been preordained by whoever, God, whatever? I mean, these are PhDs, and they're putting God into the picture in subtle ways. They're saying, the future's already happened. So who defined the future? Who made me do what I do? I mean, or what I'm planning on do? Is there someone who's guiding me, or do I really think I have free will? And I really don't, because the blocked universe that these people are talking about already exists, already is there, and all we're doing is walking on footsteps. Is this the case? Is there a file cabinet out there, God's file cabinet, where all I need to do is pull, if I could access it, right? I'll pull the file out for Bill Gates, I don't know, in the year 2030, if we make it that far. I pull the file and I can read what I'm going to be doing, what I'm going to be thinking, every little second, every microsecond, every motion I do with my little finger. All that stuff is already in there. That must be some computer, just for one person, let alone for all of humanity. But these people believe in this stuff. And this stuff, these are religious notions that have been around for centuries, by the way. They were discussed by St. Thomas and St. Augustine, hundreds of years ago. And these people are reviving the same exact concepts, and now under so-called, scientific context, right? And they're saying, oh no, but now we're applying science to this. And what are they saying? Well, they're saying the same thing that St. Augustine said. It's like, it's already preordained, and you've got no choice. No free will. Okay, so if you thought you had free will, you're wrong. If you kill someone tomorrow, hey, you just say, hey, sorry, judge, God made me do it, or the devil made me do it, whoever. I had no choice in the matter because it was already preordained. My God. Okay, here's another fellow, and I think a lot of you know him, and he's Brian Greene, and he talks about the reverse time, the arrow of time going backwards, and reconstructing cups that have broken on the floor. Unbelievable. But here it is. Let me see if I can put him up here. Give me a second. There he goes. Why don't we ever see events unfolding in reverse order? The arrow goes back to the shooter. According to the laws of physics, this can happen. Now, how's that for a magic trick? Okay, the arrow goes back, okay, to the archer. And then the glass of wine reassembles itself and goes back. Hollywood can do anything, really. The question is He says these are the laws of physics. Is this physics? Or is this just a bunch of nonsense, idiocy from Harvard and Cambridge? I mean, if you really believe this nonsense, you got to screw loose. And if these people have PhDs and this is what they've come up with, this is what they peddle out there, we got to start wondering about their state of mind, let alone whether they're really physicists and whether mathematics is the language of physics. This should make you stop and think. If you know, it should be a slap in the face to wake you up. You know, I mean, come on. Okay, and here's a couple more. See if I can get him up here. This is another fellow who's coming up on the ranks. Okay. After Carl Sagan and Brian Greene. Well, this one is probably the new generation. His name is Sean Carroll. And what he says, I mean, he's an expert, right? He says the universe will expand forever. Here you have this space-time, right? And it's expanding, right? It's expanding, expanding, expanding. And you say, well, is there a moment where it'll stop? I mean, if these people believe that 14 billion years ago, right, the universe had an origin from nothing, energy, whatever, God, whatever, we don't care, right? It had an origin. Why would it continue forever? You would think it begins and ends, right? But they say, no, it had a beginning, but it has no end. This is what they came up with. And here's Sean Carroll saying it. Let me get him up here. It says, the universe will expand forever. Back when I was your age, we didn't know what the universe was going to do. Okay? Some people thought the universe was going to recollapse. But if there's dark energy and dark energy does not go away, the universe is going to keep expanding forever and ever and ever. 14 billion years in the past, but an infinite number of years into the future. Now, how's that for a prediction? Okay? Nobody can, you know, contradict them. I mean, because, you know, I can say anything. I can talk about angels, saying the angels will carry me to heaven when I die. Well, you got to wait until I die, right? Now, in my case, maybe you can figure out if angels did carry me to heaven. But when I give you a prediction for the year 3000, you know, that's a loose cannon. That's what I mean, well, what are you going to do? Say, no, you're wrong. Let me go to the future, find out if it really happened. You know, so these people have that notion, and one of the ideas behind that, the reason they come up with this is this one here. They had this WMAP project, and which involves satellites and measurements and so on, and they prove that the universe is flat. You can see it looks like a board. Yeah? And you're saying, I made this up. No, this was in Astronomy magazine. I showed this a couple of weeks ago. This was in Astronomy magazine. This they published. They have room for this editorial space for this nonsense, for this junk. You want to print something saying that relativity is bunk, they won't let you print it because it's their club and their magazine, right? So they can print whatever they want. And this stuff they print, they say, well, this is important for the public to know that the universe is flat like a washboard, you know, one of those ancient washboards. Or this is the universe according to these people. Flat universe. Astronomy magazine, 1999. So here, all these people have these weird notions. We have negative time, we have imaginary time, we have time dilation. We have time as the fourth leg of a religion called space-time. You know, what are we supposed to think of this? Have they made a monster out of time? Is this what we're supposed to conclude? Or is this real? You know, I would think that all these people have lost it. They're floating in the air. They no longer have their feet on the ground. I can't even take them seriously. And yes, if they run the show, you know, you're not allowed to print stuff against them in their own magazines. And guess what? They end up proving their foregone conclusions. They say, oh, here we had, like one test was gravity probe A. And gravity probe A, you know, they were able to measure how far up to put the satellites. Essentially, that was a precursor to Gravity Probe B, which later said, what did that prove? Prove that we drag space around. And you say, well, hold it, let me criticize that. No, they won't allow you to. They've already proven it. It's you who has to memorize what they've proven. And that's what they pass on to the new generation. What happens? A person goes to college and he starts, there's two types of people. There's those people who say, well, this is all nonsense. Well, that guy doesn't make it past the course, or he drops out, or he changes career. He said, I'm going to become an engineer or a lawyer or whatever. And the guys who stay on board are the guys who suck up, are the guys who are going to go up there and say, oh, yeah, space-time, yeah, black holes, yeah, Big Bang, so they'll just repeat the catechism. They get jobs, they get good positions because, they were able to bow down. These are choir boys, yes men. And so now these people get put into important places, good salaries, and they perpetuate the religion. And so we have this body of so-called physicists, mathematical physicists, and they have all these big positions in colleges, in centers like NASA or CERN, accelerators and so on. And these are the people that go to those places: the people who sucked up, the people who passed the test, the people who wrote a thesis that their supervisor approved. Okay. And so, what we've done is we created a system where we perpetuate these ideas. And then you can't fight these ideas because you're not allowed to publish in their magazines, right? Or if you do, maybe, I was able to publish a couple things out there, but it's like, low key. It's like nobody pays attention to you because you didn't come up with a new equation or something. And what you're trying to do is criticize the physical interpretations. And they don't care about physical interpretations anymore. All they care about is being able to, to do their math, their equations, play around with the variables. And then, they become famous and some reporters say, hey, we'd like to interview you for a documentary. They're not going to go to me or someone else that no one knows. No, they're going to go to these guys. And they bring them on board. These people are able to tell the public now their physical interpretation without any criticism. And they can say whatever they want. They can say, look, space-time is warped. Why can't we imagine it? Well, it's four-dimensional. We can't imagine four-dimensional things. We can only imagine three-dimensional things or lesser, two-dimensional ones. And so they get away with all kinds of nonsense, all kinds of arguments, and you can't put them against the wall. And even if, a guy like me goes on board and starts criticizing them, they would say, hey, how many people do you have behind you? Look at all the ones we have behind us. So it's a voting thing. It's like we're majority and we run the show. And so there's no way to approach the problem right now. We've painted ourselves into a corner as humans, right? We painted ourselves into a corner because now we're not able to challenge any of these theories anymore. Okay? The only way you're going to be able to challenge them is printing through a magazine that they control, and the only way you're going to be allowed to publish there is if you put some kind of equation. They don't want physical interpretations. Physical interpretations is a prerogative of the guy who made it to the top within that club, and he's able to tell the public his physical interpretation. And he's going to say some nonsense. People say, hold it, but that sounds like idiocy, like poppycock. And the guy said, yeah, but it's what the equations show. And we proved it with such and such experiment, which again is a physical interpretation of theirs. And when you start trying to criticize them, you'll never get to be able to publish something to criticize what the guy said. So they get away with murder. They can say whatever they want these days, and there's no way to challenge them. Anyways, time has become a monster, especially in the 20th century and beginning of the 21st. We're not going to be able to roll time back. Space-time, this religion that includes black holes, dark matter, dark energy, Big Bang, all that show, all those parts of that show, they're integral part of space-time. we're not going to be able to erase any of that anymore. And so it's become a religion now. It's just belief. It's just pray to space-time, pray to the black hole. They even take pictures of so-called black hole. You're supposed to accept it on the basis of their testimony alone. They say, yeah, we took this picture of all this matter rushing into a black hole. Well, for all I know, it could be angels, but they tell you it's a black hole and you got to believe it. What are you going to do? How are you going to challenge that on a rational basis? Say, well, tell me what a black hole is. No, they'll never tell you that. They'll say, well, we don't really know what a black hole is. Or like I put in one of my videos, they asked a lot of these guys, Michio Kaku and some of the others, and ask them, what is a black hole made of? And they all drew a blank. I don't know. What is a black hole made of? I don't know. What's made out of mass, right? What is mass? It's nonsense. It's mathematical nonsense. And so on. So we have this religion, and right now you have two choices. You either go against it or you fall in and start praying to space-time and Einstein and all these other gurus that have popped up and making thousands, if not millions of dollars by spreading nonsense. Okay, starting Wednesday, I'm going to start criticizing some of these folks one by one. Let's see what these guys have to offer to science. Not only for relativity, space-time, black holes, dark matter, all that stuff. No, also the quantum guys, because they also have irrational theories. You're not allowed to question their physical interpretations because they themselves say it's irrational, we don't understand it, but that's it, we've proven it. So they prove it, but they don't understand it. So what did they prove? I don't know. So I'm going to be attacking some of these celebrities out there that make lots of money and come up with nonsense, especially physical interpretations. And the reason they can get away with, or the reason they ended up with that, right, that they cannot answer the questions is because they don't use objects. See, if you're going to give a physical interpretation to the universe, to the workings of the universe, which is, I guess, what physics was all about, or was supposed to be about, right? We're supposed to know how Mother Nature runs her shop. And the only way we're going to figure that out is by making the invisible visible. You're going to have to go out there and say, what does Mother Nature use to do gravity? What does Mother Nature use to do light? And you might say, well, she doesn't use anything because I can't see it or I can't touch it. Well, then, in effect, you're putting spirits in that same space. You're saying that gravity is done with spirits. Because, if a ball falls to the floor, something came in contact with the skin of the ball. And I don't know how else to make you understand that. If you don't understand it, you're an irrational individual. Something had to come in contact with the skin of the ball. And all you got to do is identify that invisible, intangible something. This is not what these people do. What these people do is say, hey, we can do this with mass, we can do it with energy, we can do it with force field, with all these concepts. But you can't use a concept as a physical object. And this is where the problem is. And so I'm going to be criticizing some of these people in the next few weeks, show you what they're saying to see if it sounds rational to you. Their physical interpretations, and I think you're going to conclude that they are irrational individuals, and you wonder how they ever got a degree.